Okay, folks, this video is not meant to help you solve each and every problem on the test for test corrections. It is meant simply to give you some guidance that you can apply the process to the various problems that you got wrong so that you can make your corrections. Okay, let's get started for slope. The slope formula, remember they were looking for the formula, we were not looking for rise over run. The formula is y2 minus y1, and that is over x2 minus x1. The slope-intercept form for a linear equation is y equals mx plus b. This formula will help you solve problems numbers 1 and 2, help you make test corrections on problems 1 and 2. We'll move on using this slope formula to solve other problems that are on the assessment. So I got a chance to go through the assessment, and I found that many students were trying to do shortcuts in terms of trying to just jump to finding the slope and finding the y-intercept without actually going through the steps. So this is not in slope-intercept form. We need to put it in this form. And this is how you do that. So we have the problem 2x plus y equals 5. The goal is to get y by itself and in this state. So we're going to subtract 2x from both sides. That leaves us with y is equal to negative 2x plus 5. If you recall, m is the slope, the y-intercept is b. The y-intercept is b. So now the answer to this particular problem here for this equation, the slope is negative 2. It's not negative 2x, it's just negative 2. The y-intercept, and it's asked to be putting it in coordinate in ordered pairs, so this would be 0, 5. The next part is that now we have to graph this particular equation. So what we're going to do is we're going to first plot the point for the y-intercept, and that is at 0, 5. So our first point is here. Now our second point to make the line will be generated from the slope. So we're starting at this point here, and our slope here is negative 2. So we're going to go down 2 and over 1. So now I have a slope graphed for this equation of a line. This explanation will help you solve and correct problems 7 and 8. Alrighty, so for 7 and 8, you were asked to find the slope and then find the y-intercept. So for this particular problem here, any value of y up and down the y-axis, x will always be negative 3. So whatever number y is, if y is negative 1, x will always be negative 3. If y is a positive 3, x will always be a negative 3. So here we're graphing a line that has an undefined slope. And if you notice, it does not travel through, there is no y-intercept. There is no y-intercept on this. You would apply this same this concept to problem number 7. Problem number 8 will be basically the same thing. Say, for example, it had y equals 3. Change colors here. So no matter what x is, y will be 3. If x is 2, y is 3. If x is negative 5, y will be 3. And you'll have something that is a 0 slope. And then with that 0 slope, the y-intercept would be 3 for the y-intercept. Let's continue on. This explanation will help you solve and correct problems 9 and 10. So here again the idea is to generate y equals mx plus b. Shortcuts will not get you to this. You'll be making numerous mistakes. So the first goal, subtract 4x from both sides. That leaves us with 5y minus or equals negative 4x plus 15. We're going to divide by 5 on both sides. So y is now negative 4/5 x plus 3. The slope in this instance is negative 4/5. The y-intercept here, and we're asked to put it as an ordered pair, the y-intercept is 3. 0, 3. The x-intercept, we figure that out by substituting, and we're making a table so that when x is 0, y is 3. Well, what will happen when y is 0? So some number. When y is 0, let's just change here. When y is 0, x is going to be negative 4/5 x plus 3. Let me just scroll down a bit. We're going to subtract 3 from both sides. And we have negative 4/5 x by itself. I have to extend the page a little bit. Next, what we do, we have to isolate the variable, so we'll multiply by the reciprocal in this case, by negative 5/4. And here, now x would be all by itself, and in this case, this would be graphed at 15/4, and that would then be converted. 4 goes into 15 3 times. So we're looking at, on the graph, that we would approximate that at 4.75 or 4 3/4. So in this particular instance, you're going to be coming up with whole numbers. I was giving you a little bit more challenging problem with that. Okay, next we're going to be correcting problem 11. You're going to be writing it in slope-intercept form for the equation of a line. Remember, the slope-intercept form is y equals mx plus b. We know that b is 2. So let's just start substituting back in. Now from this point here, what do we do? This is in increments of 2. So in order to get to the next point where it intersects right here, this would be a very, very difficult point to graph, but we can graph this. This is going down in increments of 2. So it's going down 4, and it's going over 2, 4, 6, and it's going over 6. So the slope for this is negative 4/6 x plus 2, and then we would simplify that to be negative 2/3 x plus 2. Last problem. This will help figure out what the slope intercept in an equation of a line for given this data here. So what are we going to do? What do you notice here? If you recall from past experiences, this is being increased by 2. What's happening here? This is being increased by 6. So it looks like we have this as our y-intercept. So our y-intercept, remember, if we're going with a y equals mx plus b, b is the y-intercept, so we know that b is going to be 1. X stays the same, y stays the same, the plus sign stays the same. Now we have to figure out what m is. So we're going to take, if you recall from the very beginning with the 2 points, the change in y, which is 6, over the change in x, which is 2. That is simplified to 3. So here, the slope-intercept equation for this line, or for this set of data, is y equals 3x plus 1. So your homework is to complete and make the test corrections, return it after break, and you will also have a practice packet to complete more problems so that we're ready for a reassessment.